Alright, welcome back, math friends. We are reading OpenStax 3.3 Subtract Integers. Learning objectives. By the end of this section, you will be able to model subtraction of integers, simplify expressions with integers, evaluate variable expressions with integers, translate word phrases to algebraic expressions, subtract integers in applications. Be prepared 3.4. Before you get started, take this readiness quiz. Simplify 12 minus 8 minus 1. If you missed this problem, review example 2.8. So just from observation, you should solve inside the parentheses and then subtract from 12. Okay, we got a couple more be prepared problems you can try. Model subtraction of integers. Remember the story in the last section about the toddler and the cookies? Children learn how to subtract numbers through their everyday experiences. Real-life experiences serve as models for subtracting positive numbers, and in some cases, such as temperature, for adding negative as well as positive numbers. But it is difficult to relate subtracting negative numbers to common life experiences. Most people do not have an intuitive understanding of subtraction when negative numbers are involved. Math teachers use several different models to explain subtracting negative numbers. We will continue to use counters to model subtraction. Remember, the blue counters represent positive numbers, and the red counters represent negative numbers. Perhaps when you were younger, you read 5 minus 3 as 5 take away 3. When we use counters, we can think of subtraction the same way. Manipulative mathematics. Doing the manipulative mathematics activity, subtraction of signed numbers, will help you develop a better understanding of subtracting integers. We will model 4 subtraction facts using the numbers 5 and 3. And so actually it looks like one line of these numbers, but these are actually, there are 4 sets of these. 5 minus 3, negative 5 minus 3, minus 5 minus 3, and finally 5 minus 3. Example 3.30, we will model 5 minus 3, and you'll see that, like chapter 3.2, the interpretation is 5 minus 3 means 5 take away 3. Model the first number, start with 5 positives. We will take away the second number, so we take away 3 positives. Find the counters that are left, and that's 5 minus 3 equals 2. The difference between 5 and 3 is 2. Got some try it problems. And we now are example 3.31, model minus 5 minus 3. So we'll interpret this expression as -5 minus a -3 means -5 take away -3. Model the first number. Start with 5 negatives. Take away the second number, so take away 3 negatives. Find the number of counters that are left, and you'll see there are 2 negatives, and we read this as -2. So the difference between -5 and -3 is -2. We have a couple try-it problems. Notice that example 3.30 and example 3.31 are very much alike. First, we subtracted 3 positives from 5 positives to get 2 positives. Then we subtracted 3 negatives from 5 negatives to get 2 negatives. Each example used counters of only one color, and the takeaway model of subtraction was easy to apply. Now, let's see what happens when we subtract one positive and one negative number. We will need to use both positive and negative counters, and sometimes some neutral pairs too. Adding a neutral pair does not change the value. Example 3.32. We will model -5 minus 3. Interpret this expression. -5 minus 3 means -5 take away 3. Model the first number. Start with 5 negatives. Take away the second number. So we need to take away 3 positives. But there are no positives to take away. Add neutral pairs until you have 3 positives. Now take away 3 positives. Count the number of counters that are left. And so the difference of -5 and 3 is -8. You can count -8 counters. We have a couple try problems. In example 3.3, we now model 5 minus -3. Interpret the expression. 5 minus -3 means 5 take away -3. Model the first number. Start with 5 positives. Take away the second number. So take away 3 negatives. But there are no negatives to take away. So we add neutral pairs until you have 3 negatives. Then take away 3 negatives. Count the number of counters that are left. The difference of 5 and -3 is 8. 5 minus -3 equals 8. We have some try-it problems and examples here. Example 3.34, model each subtraction. And let's go observe the solution. 8 minus 2, this means 8 take away 2. So we start with 8 positives. Then we take away 2 positives. And how many are left? 6. We go to B, -5 minus 4. This means -5 take away 4. Start with 5 negatives. You need to take away 4 positives. add 4 neutral pairs to get 4 positives, take away those 4 positives, and how many are left? Minus 5 minus 4 equals minus 9. Okay, C, 6 minus minus 6. This means 6 take away minus 6. So we start with 6 positives. We add 6 neutrals to get 6 negatives to take away. And we remove 6 negatives. How many are left? 12. 6 minus minus 6 equals 12. D, minus 8 minus minus 3. This means minus 8 take away minus 3. We start with 8 negatives. We take away 3 negatives. How many are left? Minus 8 minus minus 3 is equal to minus 5. Okay, and we have some try it problems. In example 3.35, model each subtraction expression. A, 2 minus 8, B, minus 3 minus minus 8. For A, we start with 2 positives. We need to take away 8 positives, but we only have 2. Add neutral pairs until there are 8 positives to take away. Then we take away 8 positives. Find the number of counters that are left. There are 6 negatives. 2 minus 8 is equal to minus 6. B, we start with 3 negatives. We need to take away 8 negatives, but we have only 3. Add neutral pairs until there are 8 negatives to take away. Then take away 8 negatives. Find the number of counters that are left. There are 5 positive counters. So minus 3 minus minus 8 is 5. Try it problems. Simplify expressions with integers. Do you see a pattern? Are you ready to subtract integers without counters? Let's do 2 more subtractions. We'll think about how we would model these with counters, but we won't actually use the counters. Subtract minus 23 minus 7. Think. We start with 23 negative counters. We have to subtract 7 positives, but there are no positives to take away. So, we add 7 neutral pairs to get the 7 positives. Now we take away the 7 positives, so what's left? We have the original 23 negatives plus 7 more negatives from the neutral pair. The result is 30 negatives. Minus 23 minus 7 is equal to minus 30. Notice that to subtract 7, we added 7 negatives. Subtract 30 minus 12. Think, we started with 30 positives. We have to subtract 12 negatives, but there are no negatives to take away. So we add 12 neutral pairs to the 30 positives. Now we take away the 12 negatives. What's left? We have the original 30 positives plus 12 more positives from the neutral pairs. The result is 42 positives. 30 minus minus 12 is 42. Notice that to subtract minus 12, we added 12. While we may not always use the counters, especially when we work with large numbers, practicing with them first gave us a concrete way to apply the concept so that we can visualize and remember how to do the subtraction without the counters. Have you noticed that subtraction of signed numbers can be done by adding the opposite? You will often see the idea, the subtraction property, written as follows. Subtraction property, A minus B is A plus minus B. Look at these examples, these two examples. We see that 6 minus 4 gives the same answer as 6 plus minus 4. Of course, when we have a subtraction problem that has only positive numbers, like the first example, we just do the subtraction. We already knew how to subtract 6 minus 4 long ago, but knowing that 6 minus 4 gives the same answer as 6 plus minus 4 helps when we are subtracting negative numbers. Example 3.36, simplify A and B. We have 13 minus 8 and 13 plus minus 8. And for B, minus 17 minus 9 and minus 17 plus minus 9. So the solution, 13 minus 8 and 13 plus minus 8, we subtract to simplify. 13 minus 8 is 5. Add to simplify, 13 plus minus 8 is 5. Subtracting 8 from 13 is the same as adding minus 8 to 13. And B, minus 17 minus 9, minus 17 plus minus 9. Subtract to simplify. Minus 17 minus 9 is minus 26. Add to simplify. Minus 17 plus minus 9 is minus 26. Subtracting 9 from minus 17 is the same as adding minus 9 to minus 17. We have some try-it problems here. Now look what happens when we subtract a negative. We see that 8 minus minus 5 gives the same result as 8 plus 5. Subtracting a negative number is like adding a positive. Example 3.37. Simplify. A. 9 minus minus 15 and 9 plus 15. B. Minus 7 minus minus 4 and minus 7 plus 4. Solution 9 minus minus 15 and 9 plus 15. Simplified, subtract to simplify. 9 minus minus 15 is 24. Add to simplify. 9 plus 15 is 24. Subtracting minus 15 from 9 is the same as adding 15 to 9. And B, minus 7 minus minus 4 and minus 7 plus 4, we subtract to simplify. Minus 7 minus minus 4 is minus 3. Add to simplify. Minus 7 plus 4 is minus 3. So we can see that subtracting minus 4 from minus 7 is the same as adding 4 to minus 7. Some try-it problems. Look again at the results of example 3.30 to example 3.33. 5 minus 3 is 2. That's 2 positives. Minus 5 minus minus 3 is minus 2, and that's 2 negatives. When there would be enough counters of the color to take away, subtract. So minus 5 minus 3 is minus 8. So 5 negatives want to subtract 3 positives. We need neutral pairs. When there would not be enough of the counters to take away, add neutral pairs. And here 5 minus negative 3 is 8. 5 positives, we want to subtract 3 negatives. We'll need neutral pairs. Table 3.4, subtraction of integers. And example 3.38. Simplify minus 74 minus minus 58. Solution, we are taking 58 negatives away from 74 negatives, so we subtract, and we get minus 16. Example 3.39, simplify 7 minus negative 4 minus 3 minus 9. Solution, we use the order of operations to simplify this expression, performing operations inside the parentheses first, then we subtract from left to right. Simplify inside the parentheses first, subtract from left to right, subtract, and we get 5. Some try-it problems. And example 3.4, simplify 3 times 7 minus 4 times 7 minus 5 times 8. Solution, we use the order of operations to simplify this expression. First we multiply, then we subtract from left to right. Multiply first, then subtract from left to right. Then finally subtract, and we get minus 47. Some try-it problems. Evaluate variable expressions with integers. Now we'll practice evaluating expressions that involve subtracting negative numbers as well as positive numbers. Example 3.41, evaluate x minus 4 when a x equals 3, b x equals minus 6. Solution, to evaluate x minus 4 when x equals 3, substitute 3 for x in the expression. Substitute 3 for x, 3 minus 4, subtract, minus 1. B, to evaluate x minus 4 when x equals minus 6, substitute minus 6 for x in the expression. Substitute minus 6 for x, subtract, and we get minus 10. A few try-it problems. An example 3.42. We evaluate 20 minus z when a, z is equal to 12, and b, z is equal to minus 12. Solution, A, to evaluate 20 minus z when z is equal to 12, substitute 12 for z in the expression. Doing so, You subtract, and we will get 8. B. To evaluate 20 minus z, when z is equal to minus 12, substitute minus 12 for z in the expression. You'll notice that's the same direction, well, similar directions. The difference is that parentheses where the z was. What helps me is anytime you see a variable, put a parentheses there and put that value that you want to substitute into that parentheses. And when you subtract, you get you get positive 32. Okay, some triad problems. Translate word phrases to algebraic expressions. When we first introduced the operation symbols, we saw that the expression a minus b may be read in several ways as shown below. A minus b, a minus b. The difference of a and b, subtract b from a, b subtracted from a, b less than a. Be careful to get a and b in the right order. That's figure 3.18. Example 3.43, translate and then simplify. A, the difference of 13 and minus 21. B, subtract 24 from minus 19. Solution, A. A difference means subtraction. Subtract the numbers in the order that they are given. So we first translate it. The difference of 13 and minus 21 is 13 minus 21. Simplify, and we get 34. B. Subtract means to take away, or to take 24 away from minus 19. Translate, subtract 24 from minus 19 is minus 19 minus 24. Then simplify, and that's minus 43. We have some triad problems. Subtract integers in applications. It's hard to find something if we don't know what we're looking for or what to call it. So when we solve an application problem, we first need to determine what we are asked to find. Then we can write a phrase that gives the information to find it. We'll translate the phrase into an expression and then simplify the expression to get the answer. Finally, we summarize the answer in a sentence to make sure it makes sense. How to solve application problems. Step 1. Identify what you are asked to find. Step 2. Write a phrase that gives the information to find it. Step 3. Translate the phrase to an expression. Step 4. Simplify the expression. Step 5. Answer the question with a complete sentence. Example 3.44. In the morning, the temperature in Urbana, Illinois was 11 degrees Fahrenheit. By mid-afternoon, the temperature had dropped to minus 9 degrees Fahrenheit. What was the difference between the morning and afternoon temperatures? Solution. Step 1. Identify what we are asked to find. And that is the difference between the morning and afternoon temperatures. Step 2. Write a phrase that gives the information to find it. That is the difference of 11 and minus 9. Step 3. Translate the phrase to an expression. The word difference indicates subtraction. 11 minus 9. Step 4, simplify the expression. That's 20. Step 5, write a complete sentence that answers the question. The difference in temperature was 20 degrees Fahrenheit. And we've some try it problems. Geography provides another application of negative numbers with the elevations of places below sea level. Example 3.45. Dinesh hiked from Mount Whitney, the highest point in California, to Death Valley, the lowest point. The elevation of Mount Whitney is 14,497 feet above sea level. And the elevation of Death Valley is 282 feet below sea level. What is the difference in elevation between Mount Whitney and Death Valley? Step 1. What are we asked to find? The difference in elevation between Mount Whitney and Death Valley. Step 2. Write a phrase. Elevation of Mount Whitney minus the elevation of Death Valley. Step 3. Translate. 14,497, that's the elevation of Mount Whitney, minus, is that minus? Minus 282, that's the elevation of Death Valley. Step 4, simplify. That's 14,779, and I would use a calculator if you have to. Step 5, write a complete sentence that answers the question. The difference in elevation is 14,779 feet. There you have it. So we have some try it problems here. Now, managing your money can involve both positive and negative numbers. You might have overdraft protection on your checking account. This means the bank lets you write checks for more money than you have in your account as long as they know they can get it back from you. Example 3.46. Leslie has $25 in her checking account and she writes a check for $8. A. What is the balance after she writes the check? B. She writes a second check for $20. What is the new balance after this check? C. Leslie's friend told her that she had lost a check for $10 that Leslie had given her with her birthday card. What is the balance in Leslie's checking account now? Solution A. What are we asked to find? The balance of the account. We'll write a phrase that's $25 minus $8. We translate that. That's $25 minus $8. We simplify, and that becomes $17. Now we write a sentence, or a sentence answer. The balance is $17. B. What are we asked to find? The new balance. Write a phrase that's $17 minus $20. Translate. $17 minus $20. Simplify, that's minus $3. Write a sentence to answer. She is overdrawn by $3. C. What are we asked to find? The new balance. Write a phrase. $10 more than minus $3. Translate. Minus $3 plus $10. Simplify it. That's $7. Write a sentence answer. The balance is now $7. So we have some triad problems. And this is chapter 3.3. We have some section 3.3 exercises, some resources above, and as usual, I recommend that you practice some of these problems to get familiarity. You don't have to memorize the numbers, but I think it's important to get comfortable with the patterns and the forms. Because many of these problems will have different numbers, but they will introduce very similar, if not the same, set of operations. They'll ask the same questions with different numbers. So don't try to memorize the numbers. And there you have it. Chapter 3.3, subtract integers.